Okay, so the meeting is it's now being recorded, and by continuing to be in this meeting, you are all consenting to be recorded. So welcome everyone to the module 3 of a Data 460 course and section 6380. You know the drill, so I'm not going to go over this thing again. Again, we're a small crowd, so I'm not going to go over this slide again and again. You know it all. So I'm going to just skip this and go right into the agenda for today. And first things, we'll talk about computer vision. That's what your module is currently about. I'll try to keep up with the same approach that I took the last time, which is just supplementing some information, helping you with a project that I'd worked on, and a little bit on sentiment analysis, and try to keep up with the same approach, a practical approach. My goal is to share with you some resources that are very, very fascinating, very interesting, that may help you to gain some more knowledge, information, and get to know what those exciting projects are out there on computer vision. Then we'll talk about assignment 3. And finally, any questions on assignment 3 or, on module 3 or, anything that you have in mind about this course. Okay. So, all right. And before we get to computer vision, once again, a quick retrospective in the last couple of weeks, weeks 4 and 5. Well done on your assignment too. Excellent. I mean, you guys all nailed it. Did a fantastic job. Some of you had some short answers to the questions, but I kind of gave you that feedback. At this stage of your degree, you really want to elaborate, and a paragraph could be just more than a few or a couple of lines. But otherwise, I think you all did it from the perspective that you knew the concepts very well, the core concepts, and you knew what to do, and you were all successful with what was on hand. Also, great job on the tutorial. I believe it was one of the easiest tutorials you could get at this stage or at this kind of a course, at the level 4 course. But hey, you learned something about Amazon recognition that you may use in future, or at your workplace or wherever you think about doing something more elaborate, more advanced than what your assignment 3 could be on Amazon recognition. You would know about this tool, and you'd probably try your hands on and try to make use of it, right? So good job again. I think you followed the instructions, and you applied and saw all the different things and the power of Amazon recognition tool within AWS. Week 1 was once again a good discussion week. Although I thought there's an opportunity that I saw some of the posting and comments coming in pretty late in the week. So I think we have an opportunity to bring that back on earlier, as you did in the first couple of discussions. I think we have an opportunity. I saw that this particular discussion week. Having said that, I will give you again for the spirit that you maintained, and engagement and engaging and participating with your classmates, putting up some very quality discussion points. So, very well done on that. I would not take away anything from you on that aspect. As I said, the only one thing now, since you have only one discussion left, make sure you kind of just get it out on time as early as possible. Get into some good discussion. As I keep saying that, this is one component that you learn from each other. And it's very important, because you would learn much beyond what you have as part of your learning material within the course, or the assignment or the tutorials you could be working on. And so because many of you are doing some extensive research, going out on the internet, using different resources to bring in those discussion points. And that's huge. I think that's very important, very precious, I would say, because you are now all within a week's time, you getting to, read all that stuff that, your peers would have read in more extensively, and then they're summarizing it for you. So take advantage of that. And then finally, also take advantage of these webinars, for understanding live, or have this, in one-on-one, not a session where you could be, almost like one-on-one with me, come with questions, be with your classmates, with your peers here. So take advantage of that. Or if you cannot be live for one reason or the other, watch these recordings, because, your peers could be asking some questions that could be important, whether it's about the assignment, whether it's about the module that you're working on. So do take advantage, right? At least if not being live here, then watching the recordings. Okay. All right. So with that, and before I get into the some of the resources here, we have one more webinar left here. So a couple of weeks from now, the only one webinar, the fifth one in the series of 5 webinars. It is exactly a couple of weeks from now on the Thursday. So you do mark your calendar. And as always, I will be sending out the invite to you in advance earlier in the week. Okay. So coming over to computer vision, I'd like to open up with a discussion on a couple of, or just sharing with you a couple of resources. And one of them is this open data sets called Scale. It has a very wide variety of data sets that I thought I would share with you if you have not already, found out about it. But very elaborate and an extensive data set for images, for vision, for audio, all sorts of data is out here. And this is also subscription-based, website here, but you don't have to subscribe. If you're not looking for very enhanced and extensive data set, then you really don't have to subscribe and pay for it. But there under resources, you'll find some, and many of them actually, public data sets that you can get hands-on. And this could be for, work practicing your skills, or you're working on your project or your final project, whatever that could be. But just I thought I would share this resource with you, which I loved it. I think I saw some excellent data sets that I really want to get hands-on and would continue to use this data set. Okay, so that's one. The other data set that, or the other resource I could think about is Google's DeepMind. It's one of the other resources here, or the data sets that has got a wide variety of data in here that you can get hands-on to. And both these, not just DeepMind, but even the other one as well, has got not just pure data sets, but it has got multiple, white papers, some projects being undertaken based on the data sets that are available here. So there's a lot more information that you can, some very scholarly articles that are also published here. So you can, it's beyond just getting, just the data sets, right? It's not just about getting some CSV file with all the data in there, but understanding of, or seeing some of the, projects that have been undertaken, or some research that have been undertaken. So you can go beyond just data sets on these websites. So besides these two, the other website that, or the other site that I would strongly recommend and suggest is Kaggle. Probably you know about it. You may have already used it in your past courses or your projects in the past. But again, it's a very rich data set, and you can look for any particular type, whether it's NLP or vision or in any kind of, or audio, or any kind of data set. And plus, you would see some of those data sets being used in computations, where you will find how others have really worked on it. They've published their notebooks, they've published their methodology, or you can see and go through different discussions that people had during this computation. So you can get a lot more than just data sets. You can get to know different techniques that people applied. So you can compare your work with others as well. So very rich data sets, and with excellent resources here for data sets in future. Okay. Next, so no discussion on computer vision can be complete without talking about computer vision at Tesla. So let me ask you, why did Tesla become so popular? What do you think? What was the biggest popularity for Tesla?
I mean, it probably started out with yeah.
Say again, Sheldon. Sorry.
I was just gonna say it probably started out with just being like a electric supercar. I remember when it first came out, and it was like this supercar that was electric. That was kind of ridiculous, and no one else could really afford it other than like
Yeah, the
extraordinarily
Roadstar.
rich people.
Yes. Yes. Okay. So you remember it as your first, like an introduction to EV car, right?
Hmm.
Okay. I know, Anne, you were also saying something.
Oh, I said like for me, it's just like a self-driving car. That's like the impression I have.
Yeah, the self-driving car. Okay. Anyone else? What if I tell you that this was not the first EV car ever built? Would that surprise anyone here?
No.
Not the
No,
first EV. When do you think the first EV came out on the road?
I remember watching a
Prius?
video in high school. So like that would have been like 2003, 2000, early 2000s. They were like,
Okay, early 2000 for Sheldon. Anyone else?
I only remember the Prius. I don't know if I'm pronouncing that right. Prius?
Sorry,
Toyota? The
sorry.
Toyota Prius or Prius? I don't
The
know.
Toyota Prius. Yes, you're
Yeah.
talking about that one. Okay, okay. All right, Toyota Prius. Yes, the hybrid one that was there. Okay, so you're probably also talking about late 90s and 2000s. Okay. Anyone else wants to try this out?
No, I just remember the same issue with not exactly knowing how to pronounce Prius.
No, that's okay. I know we all pronounce it in different ways. Even I pronounce it in different way until my wife owned one many years back. She got that, and that's how I learned what it is actually called. But anyway, yeah, I mean, what if I tell you the first EV came out in early 1900s? I think it was 1910 or 1911 when the first EV was actually rolled out. So EV technology wasn't new. Yeah, it's a different story that it really did. It did not become a popular choice because of multiple reasons, right? No electrical network there. The battery or technology was not solid enough to give a longer range, and it went out of fashion, out of popularity very soon. But yeah, EV actually goes back to 1910 or 1920, whenever it is, but it's early 1900s we're talking about. It took almost 100 years for these cars to come back on the road again with a bang, and now it is becoming one of the popular choices, so much so that almost every top car makers are building EVs there. They're one of the biggest thing. And if you've been following EVs or the news on EV cars, then Toyota has really ramped up their production of EV cars to an extent that it could become one of the top selling cars for Toyota at some point very soon. That's how much they're investing into EVs. But so what Tesla did differently is yes, as you mentioned about self-driving, right? And the self-driving option, the battery technology, of course, it came up with the range. Initially, it was, as Sheldon mentioned, it was one of the cars for the rich because it came up with such an exclusive car that only rich could afford it. And yeah, absolutely right. And now that the prices came down a little bit, and you see more and more cars on the road, and I'm hearing they'll probably come up with a even more economical car. But the point is they came up with that kind of a battery technology, and most importantly, I think it got popularity with its self-driving. Like you saw cars being self-driven. You saw not just the cruise control that we have been using it for so many years on all different cars, but it's taking it to the next level. And that's where one of the things that helped Tesla to get there was the technology, the computer vision, right? So computer vision, again, I'm not soliciting Tesla. I'm not affiliated with Tesla in any way. So I'm not bringing it from that perspective. The only thing I can tell you is that I drive one, and so I can bring in my personal experience. But other than that, I'm not affiliated with Tesla. I'm not going to solicit, for it as well. But the computer vision is exclusive. The fact that Tesla doesn't depend on a radar or a sensor technology, but pure vision. It has all these different cameras that are put in the cars. And think about it. Just give it a thought. Just for a second, think about, your car is being driven by these 8 cameras, or 8 or 9, whatever the different number. That I think there are around 7, 8 cameras around the car that is constantly being fed with the image. And you could be going at any speed, right? 50, 60 is these days is the minimum, and most of the highways that you go to. So you are driving at a fast speed. At that speed, you're taking in all the image, and based on that, it's making a decision in fraction of seconds in which and how to follow other cars, which lane, what is coming against it or around it, whatever it is making the decision to drive your car accurately. And this is huge, right? This is what was the biggest selling point. Not that everybody has got a Tesla autopilot. It has got some different levels of autopilot on it, but the highest level, which is called the full self-driving, which is still saying that it's in the beta mode, and it doesn't really, it's not, it calls it that way because they're still working on improving it and improving it. But having said that, there are more than 300,000 drivers that have got full self-driving, and they've been driving it for quite some time now. And after all that, and after all these years, this technology is still surviving and really doing well and better is the huge selling point for Tesla. So what is behind this, right? It's the models that are, it's all this computer vision, all the images it is taking in. It's being fed to a model that is making all this decision in real time, instantaneously, and helping the car drive itself, right? So that's huge. That's this whole autopilot technology. And just showing you that, and I just mentioned earlier that it is using all these different images. Now you could be saying, well, how does it really know what is around in the area? Does it take all the pictures from all the, from the world over, or wherever the car is driven? It has all these different pictures put in the model. No, it really can't do that, right? It's almost, close to being impossible to do that, to get in every picture clicked on, and in every region of this, or of the world, and fed to this model, right, as to what it is, or different things that you can see. There are millions of things you can see around, right? And would it be fed to a model? It's almost impossible. And so what it is really doing, it is taking in all the images. It is using your car to get all those different images, right? You could be driving on different roads. I could be driving on different ones. It is constantly taking in all the images that your car is seeing, that is being fed to this model to make it better and better. And so what it is, so that's it has ditched the radar technology. It is not using sensors. So and again, there could be pros and cons to it, but I think it has been very successful. And since last couple of years, it's completely driven based on the vision and not radar technology that some of the EVs are using. But they're probably even now going into computer vision. But Tesla has done a fantastic job with that. And how does it make it happen? It makes it happen using the Hydra nets, which is an insane neural network, almost 50 neural networks that are run together, which is building all these models and constantly updating these models with newer and newer images. And many of them this is being done with it's what this HydraNet, and the reason it's called HydraNet is it's an architecture where all these different cameras, all these different sources, they come to a shared, it has got a shared backbone where all these are fed to this shared backbone, and this backbone then feeds it into this different this specific task, right? So to this different blocks here, like one block that will be only identifying objects, one block that is only identifying traffic lights, one block that looking at different markings. So there's some tasks that are exclusively being worked upon, and this is all happening simultaneously. And what technology is being used? We are talking about neural networks. We are talking about PyTorch. We're talking about, it's a deep learning, of course. So it's a deep learning. This being framework has been used. All the things that you've learned, you've talked about, you heard about, right? It's the same thing, but it's just done in a more extensive manner, right? With using all the different, large computing resources and computing power. But it's based on the same technology that you've all been learning about. So this is one of the biggest thing, that this HydroNet, the way this deep network has been built, that it helps it to just process this millions of images, and make decisions based on that, almost real time, which is fantastic. And again, these models get updated over and over again, right? These are not stagnant or standard models that get built and nothing gets updated for months and years. These are all constantly being fed and updated. So it's new. You always get the up to date, anything that it has seen for the first time, or maybe a few times, that it would have been fed to this model. So how does it really come to know certain objects or detect certain objects in its course, right? When you're driving it. So you one of the things you'd be doing in assignment 3 is labeling the data, right? You learned about how you would label the data, and once you have a labeled data, you know the supervised learning. It will see another image. You test it with that image, and it will tell you whether that image is that particular labeled, one of the labeled objects, right? In this case, if you try to do all of that, you can't do it. So what it is doing is it's kind of it's a semi-supervised learning, what it's called about. And what is this technique is, in semi-supervised learning, you have just a very small set of labeled data. You don't have all the data is labeled, only a small set of labeled data, which could be labeled using some human resources. And then you have tons and tons of unlabeled data, right? So in semi-supervised, you kind of put the two together, right? In supervised, you need full labeled data set to predict an unlabeled image, or whatever you're looking for, an unlabeled image, right? But in semi-supervised, you have unlabeled and labeled data put together to build a model, to build a prediction model. And what it does internally, it uses the power of this labeled data to predict or to label the data in an automated fashion. As a matter of fact, AWS SageMaker can also be used to label your data, label any of your images in an automated fashion, because otherwise it's going to be impossible, right? You're going to label just 100 images, and you'll tell me the amount of time you spend on that is as good as the time that you spend on the rest of the steps there, right? So that's the amount of time it takes to label any data. And that's why it's important that we have a way to label or annotate the images that are not that are unlabeled in an automated. So once it's automated, things become much more faster. And then you can check for the accuracy, and that is being taken to use the predicted model. Now the model that is built has got a huge variety of images that are being labeled now, and that is being used to predict the the ones that is being tested, the images that are being tested out. Okay, so again, do read about it. I put in the links as I do for all the resources. So try to, and there's a lot more that you'll read about, and it's all very interesting stuff, guys. Trust me. If you have really enjoyed and going through some of these AI solutions, and especially computer vision, read about this computer vision of Tesla, and some of the other as well. I'm not just saying only Tesla, but just start with this, and you get into reading more and more about what hydranets are, how they build the model, and how they use the model, and update the model, and with the images. It's all fascinating. Okay. Another fascinating stuff is the Facebook's Seer. Facebook Seer is using something called as self-learning, which is it has no label data. It's completely unlabeled. Just by looking at the structure of the data, it is able to detect or label the images accordingly. How cool is that, right? None of it doesn't have any label data. So it's a wonderful project. Get a chance, can go and read about it if you have not so far. But it's fascinating how they've been able to come up with this, and also the way the self-learning technique works, right? Looking at just the structure, the way the image is built, or how it's being built, it understands what it is about. Very, very fascinating, very interesting stuff. The other one that is from OpenAI. OpenAI's DALL-E. Some of you may have already, or many of you would have already tried your hands on DALL-E, because it became so popular. As a matter of fact, there was one more site, I forgot, Disjoint, or I forgot the name of it, that also was very famous, very popular, and people were playing with this so much. And as much as ChatGPT became popular, or maybe ChatGPT is a little more popular than DALL-E, but this was also being used so heavily by enthusiasts, by the designers, and it helps you build all different kind of images based on the text that you provide. And it's not just the image that it would create would be only realistic images, right? It helped you create images that were sometimes so unrealistic. Like, just giving an example here is a snail made of harp, or a snail with a texture of a harp. Have you seen this? I've never seen this, right? Or an armchair in the shape of an avocado, an armchair imitating an avocado. You can never imagine how it kind of builds this kind of images. But if you look at the result, how it has kind of almost superimposed your ideas together to build such a wonderful image. And it is using a version of GPT trained model to generate these images. And it's wonderful. And I think this has been used by, it just adds to your creativity. It's used by so many designers. They've been trying different things here. And as I said, sky's the limit. It depends on how creative you want to be. And I'm sure people in fine arts and in architecture world and in designing world and in interior designing world, they're using this a lot more than just many of just the enthusiasts. I'm sure they're using it more. And I think if you're following LinkedIn or someone following the news on OpenAI, then there's a new version of DALL-E that just came out. DALL-E 3 is just came out here, and so it's already out there. So DALL-E 2 is now history. DALL-E 3 is much more interesting, and it has come up with a better interface and all that, more powerful and all of that. So yeah, I think again, just read through this, and it's if you're not played with this so far, then about time. Just go take a look at it and see. Just do a trial run and see if you like it, right? But another interesting project, how it's doing and what it is doing in the background. Okay. So besides this, some of these, there are so many of the projects on GitHub that are very interesting. Like, one of them is this first order motion model, where and Git repository, if you I'm sure you probably know about Git, but it's a wonderful resource. There are many projects that are publicly, made there, publicly, the source code is available and all of that, and it has got all the documentation on many of these sources. And so some of these projects are very interesting that you should really take a look at, as this one here, the first order motion model, where, as you can see here, the image on the left, an animated image, of our former president, and Donald Trump. He's probably, this is an image or a video that he's, probably when he's giving one of the speeches there. And what you see on the right, on the top right, are all the still images. So the video of a former president could be like a driver video, and then you apply to it as a still picture, and it gets superimposed. And the result that you see is on the bottom right there, right? You see all those still images are now giving the same speech, right? And it's making similar actions as the driver video. So again, and you may have seen this. I think this is a lot of apps on the smartphones are now, come up with this idea that you provide any of your old pictures or any pictures that you have, and they will kind of make that picture come alive and all that. So yeah, this is the I think one of the sources and the background. But if you look at the code, it's not rocket science, guys. You probably, there would be some parts of it that you may have to learn about or read about or understand. But other than that, this is all the techniques and technology that you've learned in the last few courses or few years is exactly all that here. It's in there. So nothing, again, is rocket science, but a wonderful project, again, a very fascinating one. And there's another example here, which you would probably see on some of the websites, where they let you they have a dress out there, and if let's say you want to go to this website and you want to see how that particular dress would look like on you. So you just share the picture on the website, or you upload your picture. It superimposes with the dress that you want to buy, and then you have a driver model who is kind of turning around and doing all that you'd probably do to see how the dress looks. It's exactly that driver video is fed to that still image that it has created by superimposing on the dress, and then it lets you look around and see if the dress it's a dress that you'd want to buy, or it looks good on you. How cool is that, right? This is how this technology is used in the best way. And that's why I love this project, and that's why I say I encourage you all to take a look at it, how it's neatly done. I mean, we have all these different apps, but you want to know the what's under the hood, really, what is driving this. But there's a lot of, I think many of the designer websites, the clothing websites, they're using this technology and to really get more customers and more hits to the sites, and people now knowing that without even going to the store, they can buy things off the web itself. Okay. The other cool project, and it's become a business by itself, is this video restoration. We know that we've reached a point where a lot of movies, pictures are now going to be more than centuries old, right? And this restoration is, as I said, the reason it is becoming a booming business now is because many of our videos and pictures are now going to be years and decades old, and maybe even a century old, that you want to revive. And it can be easily done, So there's this project here about video restoration, where you feed a video that could be taken multiple years back, or it's distorted or not, it's maybe the quality is not that great. You can do a whole restoration here, and it just enhances the quality of the video. So again, how does it do that, right? Again, I mean, putting up a video, uploading a video, and getting it done, it's cool, right? You can do it. Probably there are many websites that also do it, but what is under the hood? That's more important. So take a look at this project again to understand what's driving this kind of a technology, or what's this kind of technique, right? So that's one. Another one that I want to bring it to your attention is this automatic colorization project. Another project on GitHub, and what this does is, let's say if you have a black and white pictures or pictures that do not have, great colors on it, it led using the deep neural networks, it is splashing colors on this black and white pictures. And it does it in such a way, if you look at very closely to some of the results, like you see a black and white picture and you see a colored picture. And if you look at the colored picture, it looks so realistic that, yes, maybe it would have exactly looked the same. The shade of the colors, it's not just seeing that, oh, it's a ground, so let's just throw in some brown colored. It looks like there's some grass, just throw in green color. Or there's some vegetables there, it looks tomatoes, so put in red color. It just does it in a way that makes it look so real. It would almost feel like, yes, it would have looked at it in a, maybe this was how the picture actually looked like when it was first taken. Or so that's the beauty of this project, the way it is flashing colors to the black and white pictures. It's amazing. So again, take a look at this project as well when you get a chance. And another cool project is on pathology classification. One of the biggest beneficiaries of this technology in general is medical science, as you all know, right? The medical science and using the deep learning techniques, using throwing images to a model and coming up with the possibility of certain diseases, certain health conditions is becoming so popular. And I think there's a lot of investment done by different medical services, medical centers, hospitals, and research centers or research areas and labs to come up with a way to detect such health conditions. And what they're doing in this particular one, they're taking retinas of different people and different conditions of the retina, different pictures of the same retina when a person is in a certain health condition, maybe in a good health condition, or maybe having diabetes or having other health conditions and so on. And just by feeding in millions of these kind of images, it has built a model that can detect, by looking at just the eye retina of certain of the patient's eyes, that it can detect what kind of a health condition that this person may have, right? Whether it has a first stage of something, second stage of something, it doesn't have anything at all, or it's all good. It is able to do that. Fascinating project. Again, I think I'm glad that medical science has become one of the biggest beneficiaries of this, the overall AI, the machine learning technology and all, because they need to be, and we are seeing so much progress in medical science due to that. Another project that you all know is the text recognition, which is using the OpenCV project or the packages and then OCR technology. And apps like PDF scanner and Google Lens, so something that you've already seen, like extracting text within images and making sense out of it, right? And that's another cool project on GitHub. You saw that probably in your tutorial too. You had one of the images, no refund, that image that you used to classify what is written in that image. It's an image, but it just able to read through the different characters that are in the image as to what is being written there, what text is in there. Okay. And then finally, about the vehicle damage analysis, right? Just taking a quick time check here. I think we're doing great. I think I'll still be able to give some time back to you all, but we'll see. Okay, so hang in there for a few more minutes and we'll go just talk about this one last project that I want you to kind of also take a look at, is the vehicle damage analysis. Do recall if you or your parents got into accidents many years back, what would be the next step? To remember, that somebody would come over. You would either take it to a shop, to a body shop, where they would do all the assessment. They will tell you how much it would cost. It would go to the insurance. The insurance would come back and they would just, maybe approve the cost or not approve it or approve certain limit to it, whatever. But that took days because, you would have an assessor either come to your house to assess your car if it is not in a condition to be driven, or you would take somewhere else and they would look at it physically. What has changed now? You could now just upload the pictures. If you've been in accidents recently, many of the insurance companies now have an app, through this app, that you will upload all the pictures of the car. They will ask you all different types of pictures, and you send the picture, and within 24 to 48 hours, you get an estimate, you get an analysis, you get also the list of body shops that you can take your car to, or get towed, or tow your car to that place where it would be fixed, and what would the estimate look like, and what would be your cost, and what would be paid by insurance, all that within a day or two, right after you've gone through this. And what do you think that happens when you upload these images? Is that people looking at all these images and doing all this, making all these decisions quickly? I think beyond that, it's not just the humans that are really taking a look at this. There are not that many agents that are looking at it, but there are also systems that are helping them by sending all these pictures and loading it to a model that has been fed with different cars of different models, have all been fed to this model, and what the cost of each of these would be, right? Or how a particular car or model would look like. And then you have another car coming in. It is kind of estimating what all different areas of the car have been damaged, and then I come to a conclusion as to what could be a possible estimate of the car. It would be very close, may not be 100% accurate, but if you've taken all the pictures accurately, and if they correctly reflect what has been damaged, then the analysis, the assessment could be very close to being what the total would be at the end. And it gives you that kind of an assessment. And there's always going to be a little bit of plus and minus, but it all happens, very quickly. Somebody would have still go through it, but maybe they're just looking at the final result to just make sure that it makes sense when it is being sent out back to you. So that's all. But yeah, it's another vehicle damage analysis project, and it tells you how things are being done and what it does and all of that. So again, take a look at this. And but this is one thing that is not just being used by insurance companies. It's used by many agencies as well. Okay. All right. So that's all the different projects and different resources on computer vision. Very interesting, very fascinating. If you get a chance, do read and review this. It will be very helpful. Okay. Any questions? Are you guys all still with me? Are you still awake? I hope you guys all are.
Yep.
Yes.
With you.
Yeah, we still, yeah.
I just realized there's a
I
lot
do
of
have a
talking.
question.
So I want to make sure you guys are still with me. I didn't put you all to sleep. Okay, very good. Thank you for that confirmation. All right.
I do
So-
have a question about this stuff.
Sure. Go ahead. You said the question. Sorry.
So when it's handling like new information, yeah, I just had a question about when Tesla encounters something new on the road that it hasn't ever seen, how does it handle making that type of decision?
Yeah, that's a very good question. One of the reasons why many of the millions of pictures. So when you're looking at, it's not always the label data that it makes a decision on. It is also making a decision how Facebook that makes a decision on the structure of the image. So it's not always that it would find a match to the label data. It may not find a match, but then with the cost, with the structure of the image, it could make sense out of it as to what it could be closely related with, if that helps.
So it's like an association type.
Yes, that's correct. Yes, you could say it that way, some kind of an association with what it already has in its database or in its model, or how the model was trained on.
Interesting. Thank you. That's all I have.
Sure. Okay.
And Nilesh, can I add something to that?
Sure. Please go ahead.
Yeah, so it's just like reinforcement learning. As it's going on, being a new one, it might not be very accurate at the beginning, but as it's seen such again, there it will be modifying the results and it will become more accurate. So at that point, seeing new one, it will use association, but it will not be perfect. So you will not expect an accurate result for that particular thing. But as it's going on, it's learning by the way, and it's using like reinforcement learning to be more accurate.
Yeah. Yeah.
Thank
The,
you.
the only thing here, and I know that's a great ad, Ayo. Thank you so much. The only thing that I would add to what I just mentioned is that in this reinforcement learning, um, there cannot be any failures. There can only be success, right? Because failure could be fatal. And this technology could, deep dive, as you've seen with Concord, right? Again, Concord, an excellent technology. And why did that technology die? We learned how to fly faster. We learned when maybe it would have got cheaper over time as well, and may not be the only. I think the only rich could have afforded initially. Yes, they did, but it would have become cheaper over time. But the point is that even after finding out that we can fly so fast, go from point A to point B in few hours, like London to New York in 3 hours time. Wow, amazing, right? But it could not stand the test of time, and it lost out because the number of accidents, the fatal accidents that it got into. So in this case, one of the things that we have to be careful with, and that what Tesla and other companies are being careful with, is that it cannot lead it to fail. If we see a lot of accidents happening and a lot of Tesla accidents happening because of use of FSDs, guess what happens? The next thing that happens is FSD is out of, it's gone. It's no longer to be made available soon, right? Again, it will go through some trials, some tests, maybe another few years, few decades would go by until we have that technology back. So yeah, it could be using some of that reinforcement learning as well. And but it has to be just careful that it will use it in a way that it helps to understand what is in its path, and what's the most accurate thing, because it cannot fail. So I think it's whatever, even if the reinforcement learning it's using it very wisely, and it's very nicely done. So thanks, Ayo. Okay, any questions? Any other questions, comments? Excellent questions, excellent point there. Okay, so food for thought again. As we just talked about, how would you take your learning about computer vision forward? Look for all these resources, guys. 2 weeks going through computer vision is such a short time. I think this is so vast. This is a topic or a course in itself, right? And you can go through weeks and months. So there's a lot out there that you really want to get hands-on, or try to read about or learn about, or practice. So just and ensure that you're not just thinking about these resources that we just looked at. There's a very few, right? And we can't do justice to going over everything within an hour today, but go out there, research as much as you can on resources, and finding resources that can help you to build your skills on computer vision. Look at some of these projects and try to see if you can build some of these projects, or on your own. You can try it out on your own, some of these projects, and see if that. And they're not, as I said, they're not rocket science, and they will not need extensive computing resources as well. They can simply be done using your laptop. It just needs your laptop or whatever you're using. But yeah, it's some of these are really that easy to work on, or to play with, or to practice with. And as I said, just the same thing, plan to practice the knowledge and skills you have learned during this week and the next, and the past as well. Very important. If you do not practice the skills that you're learning today, it will be gone in few weeks. Trust me, 2-3 weeks or few weeks down the line, it will be gone. So it's very important that you spend in next few weeks learning about or practicing the skills that you've learned, and not just about this course, but the other courses as well. Because very soon you're going to be at the end of the journey here with your final course and final capstone project that you would want to kind of apply everything that you've learned during your journey in data science, getting your degree in data science. So, keep working on it, keep practicing it, keep looking at, keep searching for resources, for data sets to practice, and keep doing that as much as you can. And then, as I said, research areas to find images, videos, text data sets. I just shared a few resources, but there are many out there. All you have to do is just Google, just research. You'll find more data sets, maybe some of them very, very extensive, excellent data sets. And many of them are publicly and freely available. So take advantage of that, okay? With that, we'll get into talking about assignment 3. So this assignment is about loading your data into AWS S3, which will be using it as a data lake, and then make use of other AWS services such as Amazon Recognition that you just played with as in the tutorial, and use Cloud9, which is a development environment, to to undergo the process of building a classification model using the training images, and then you test the model to classify the unknown images. Okay, and most importantly, you need to submit the answer sheet. Please do not submit the instruction sheet with screenshots. So there's an answer sheet template that's available. Use that. There are 8 screenshots that are required, and this is while you go through step by step through the project, and just go through, follow the instructions. You may feel like there's many, but if you follow their step-by-step instructions, and you can't go wrong, trust me. Your TAs have really looked at this very recently. They've been successful completing this end to end. So nothing is changing the environment at the moment. One of your peers, one of your classmates have also completed the assignment. A couple of them actually completed their assignment. So yeah, so so as if you go through step by step, it will be flawless execution there. You'll get to the complete finishing line pretty soon, okay? And then I think one of the prerequisites is the tutorial on Amazon Recognition, just to understand the power of Amazon Recognition. So I think many of you are already, most of you have gone through this, but it's one of the prerequisites. And the other prerequisites are what has been provided to you in the classroom. That's what is Amazon Recognition, a 2-minute video to introduce. Then what's Amazon Recognition's identity verification, and what is Amazon Text Tract, and then a paper on that provides use cases and benefits of using Amazon Recognition. So just go through that as a prerequisite, which is really going to help you to know the Amazon Recognition better and how to work on your assignment 3. So as far as the instructions goes, there is an instruction sheet. There's a Word document called Assignment 3, Build Amazon Recognition Model Using Custom Labels Instructions. It's a long name, but just completing just what needs to be done here. And most importantly, ensure that at the end, it has got July 2023 update. So we had a minor environment change, and this assignment went through some changes. We had to remove a couple of steps to kind of simplify it. So there was an update that was done in the July 2023 class. And so this is the one that you would be really working on. And I checked the classroom. It has the correct version of these instructions. You don't have to worry, but still do check. And then you have a test recognition model in the IPython and a notebook. So that's a notebook that you would need. And then you have the data files. There are 2 zip files, one containing the training data, one containing the test data. And then you have the answer sheet that I just talked about, which is the Amazon Recognition answer sheet. It's a Word document again. And at the end of the instructions, you have the rubric, which gives you point for every step except for the last step, which gets you 16 points, all the other steps and screenshots provided will fetch you 12 points each. Okay, so again, if you go through the steps correctly, you get a screenshot accurately, there's full points for that. So this is one of those assignments where you don't want to miss out on anything, because this is one of those assignments that you can really score 100%. And I look forward to seeing that you all score 100% on this assignment. Okay, any questions?
More of a comment. I went through this earlier this week. When I was adjusting, I had to adjust the Cloud9 code at the very end of the instruction document. It wasn't printing out the labels correctly, so I had to go back and kind of adjust the code a little bit to get it to print out like the label and the confidence correctly.
Oh, is it? So what was the change that you had to make?
I just adjusted the for loop.
Oh, okay. So it could print. Okay, so the for loop, but okay, I was wondering what the change would be. So Sheldon, if you could just maybe I'll take a look at, or maybe if you can just send it to me.
Sure, I have the code and I can send it to you.
Yeah.
I did it for that one and the code for the last section too that does all four of them. I adjusted it into just having them all into one image file so that it was easier for it to process.
Okay. Yeah, I'll take a look if that's something that we need to share across to your peers as well. But I think it's still it functioned, right? Did you say it did not work, Sheldon, or was it?
I kept getting errors when I did the last two, so that's why I went ahead and adjusted the code.
Interesting. Okay, because I know Tayo just ran through the assignment very recently, as probably earlier this week, and did not run into any errors. That's why I'm kind of surprised and curious to see what changes you had to make. But yeah, let me know. And if needed to, I'll share with your peers, Sheldon. But thank you for bringing this up. Appreciate it.
Yeah, no problem.
Okay, any other questions? Any other questions besides assignment? Anything on computer vision, about module 3, about course? Are you guys all excited? You're so close to finishing this. 3 more weeks and you'll be done, guys. Okay. All right. If no further questions, let me keep up with my promise of getting you out of this place as soon as I can. At least I'm giving you 2 minutes back, if not more. But yeah, let me keep up my promise before it's again gets to the bottom of the hour. Sorry, someone was saying something. Is that you, Ayo?
Oh no, I was just smiling.
Okay. Okay. Thank you all. I'm keeping my promise. Don't forget this, okay? I'm letting you go early. Take care, guys. Bye. Good night.
Thank you.
All
Thank
right,
you.
Thank you.
Bye. Thank you.
Thank you.